Okay, coming to the next concept, that is called generation of high voltages, high DC voltages and high AC voltages. Okay, so generation of high DC voltages. Okay, there are different types of methods are there to generate high DC voltages. First one, half wave and full wave rectifiers. Half wave and full wave rectifiers. And the second one, voltage doubler circuit. And third one, voltage multiplier circuit. And the fourth one, Vande gap generator. So from this, today we will discuss that is called Vande gap generator. So today we will discuss one of the important topic, generation of high voltages by using Vande gap generator. Okay, first we will discuss construction and working principle of Vande gap generator. Okay, the Vande gap generator is an electrostatic generator which is capable of producing enormously large static potential as 20 million volts. It is designed by American physicist Robert J. Vande. Okay, so he's one of the scientists and also physicist is developed the Vande gap generator. Okay, first we will discuss how the charges are distributed on the sphere of Vande gap generator. Distribution of charges on a conductor. From this animation, we can come to the conclusion about the distribution of charges on a conductor. Here, sigma r is called a constant. Sigma r is equal to constant. Sigma is called a surface charge density. R is called a radius of curvature. From this equation, we can rewrite that is sigma is equal to constant by r. R sigma is inversely proportional to the r. From this above equation, we can infer that the surface charge density is inversely proportional to the radius of curvature. This is clearly explained by the diagram. In the diagram, A, B, C are different positions having different radius of curvature. At the point A, radius of curvature is very high and hence the accumulation of charges very small. But at the point B and C, the radius of curvature is very small and hence the accumulation of charges is very high. Thus, we can conclude that the charge distribution accumulated on pointed. Okay. The radius of curvature at point A is very high. That's why the accumulation of charges on the sphere is very less. But the radius of curvature is more. That's why the accumulation of charges are more. And here also B and C points, the accumulation of charges are more because of radius of curvature is very small. Okay, that's why this in Vande gap generator, the sphere must be in a uniform manner. Okay, the sphere must be in a uniform manner. That's why these charges on the sphere is uniformly distributed. And then coming to the working principle and construction of Vande gap generator. Vande gap generator principle. Vande gap generator works on the principle of electrostatic induction and action of points. This animation describes about parts of Vande gap generator and working principle of Vande gap generator. Description of the parts of the Vande gap generator. A Vande gap generator consists of hollow metallic sphere A. The sphere is mounted on an insulated pillar. B and C are two fixed pulleys. A belt made up of silk move over the two pulleys B and C. D and E are the two fixed combs. D is connected to a battery of 10 power volts. The other end of the battery is connected to the ground. The pulley is continuously rotating by means of electric motor. The upper comb E is connected to inner side of the hollow sphere. A. Working of the Van de Graaff generator. The comb D is connected to the battery of high voltages potential. The high potential from the battery ionizes the air near the comb D. That is, the air molecules are separated into electrons and positive ions. The electrons are attracted towards the comb E and the positive charges are repelled towards the belt and stick on it. While the belt moves upwards due to electrostatic induction, the comb E appears negative charge and spheres appears positive charge. Due to the high negative potential on E, the air gets ionized. The positive charges and attracts toward the comb E and negative charges repel towards the belt and neutralize the positive charges on the belt. Therefore, while the belt comes downwards, it has no charges. Therefore, each and every time the positive charges are uh, it goes on increasing on the sphere, it attains some limiting value. After this stage, no more charges can be placed on the sphere. It's leaking to the surrounding air, and due to the ionization of the air, the leakage of air can be air surrounding to the air can be reduced by accumulated in a gas in each chamber at very high pressure. The very high voltages can be produced by Van de Graaff generator. So this is the concept of generation of high voltages by using Van de Graaff. Try to construct a generation of high voltages by using Van de Graaff generator again. It is based on the principle that of a charged conductor is brought internally contacted with the hollow conductor on the charges. All the charges from inner conductor is transferred towards the surface of outer conductor. No matter what amount of charges is already present on outer shell. A simple Van de Graaff generator consists of a belt made of rubber running over the pair of rollers, one of which surrounded by a hollow metallic sphere mounted on insulating stand. Electrons emitted in the form of comb made up of sharp metal points is positioned near the roller. In such a way, the comb is pointed toward the rubber belt. The comb is maintained at high positive voltage by external supply, and another comb called receiver comb is positioned near the upper roller and is connected to a hollow metal sphere. A motor is connected a bottom roller in order to move the belt. When the motor is rotating, the spray comb positioned near the bottom roller, the positive charges are moving like this manner on the belt. Charges on the belt are carried upwards and collected by the receiver comb on the top of the generator. Since the upper comb is connected to the hollow conductor, the charge gets transferred to hollow sphere. Since the belt continuously carrying positive charges on the receiver comb, the spherical cell collects usually more amount of charges and develops huge amount of charges. It is very difficult to hold the more and more charges due to the force of repulsion between light charges on the dome. When the potential of spherical cell exceeds the breakdown value of air around the sphere gets ionized and leakage of charges takes place on the sphere. Then coming to the principle of electrical energy generation from electrostatic machines. When a conductor cuts magnetic flux, mechanical energy is converted into electrical energy. This is electromagnetic energy conversion principle. This is electromagnetic energy conversion principle. When conductor curves the magnetic flux, mechanical energy is converted into electrical energy. This is called electromagnetic energy conversion principle. In electrostatic machines, charged body is moved under the influence of electrostatic field and the mechanical energy is converted into electrical energy. Okay. An insulated belt with charge on it, when moved at velocity v, the mechanical power required P is equal to F into V is converted into electrical power. P is equal to V into I. So this is the construction of Vande Graaf generator, different types of parts of Vande Graaf generator. So here this is called a controllable spray voltage. This by using this uh, the controllable positive charges can be controlled by using this controllable spray voltage and lower spray point. This is called a lower spray point. That's called a bottom comb. Okay. So one comb is placed near to the bottom roller. That is called lower spray point and motor driven pulley. So this is called motor driven pulley. By using motor, so we have to rotate this roller. Okay. And then next insulated belt. This is called one of the insulated belts that is made by rubber or silk. Okay, silk type materials is made by rubber. So it's rotating on the rollers like this manner. Okay, this is called insulated belt and this is called upper pulley. Okay, and this is called upper spray point, that is called uh, uh, upper comb. Upper comb is called spray charges. Upper comb is called as a receiver comb, not spray comb. A receiver comb. A bottom comb is called as a spray comb. Positive charges are sprayed into the belt, that is called a spray comb, and the upper comb is called a receiver comb. The positive charges are collected by the receiver comb. That's why it is called as receiver upper spray point, that is called receiver comb, and it is called HV terminal. This is called HV terminal. This is called sphere. The more amount of positive charges are placed on it out of the sphere, and this is called collector. So these are the different types of parts of the Vande Graaf generator.
Then circuit operation. An insulating belt is run over the pulleys at a speed of 15 to 30 meters per second by means of motor connected to the lower pulley. Okay, that is called first one. And second, near the lower pulley, the belt is electrostatically charged by charge spray unit in the form of several needles connected to the controllable DC excitation of 10 to 100 kV. Okay, then third, the charge is conveyed to the upper end where it is collected from the belt by the discharge points connected to the inside of an insulated metal electrode through which the belt faces. The entire assembly is enclosed in an earthed metal tank filled with insulating gas of good dielectric strength. Examples: nitrogen, freon, SF6. Okay, the shape of HT electrode, that is called high voltage terminal, high tension electrode, should spherical in order to have uniform surface voltage gradient and minimum corona discharges. And next, as HT electrode collect charges, it is potential rises to high value to avoid voltage levels that may ionize the electrode surroundings. There, an optimum voltage that may be achieved from given dimensions. When charging current becomes equal to the sum of the load current, the leakage current and corona loss current, the voltage reaches equilibrium stage. To minimize distortion of electric field due to belt, it is placed within the field grading rings. Okay, ninth, the grading is provided by resistors and additional corona discharging elements. Okay. A second point, system is excited by a self-conducting inducing arrangement. A second point, system is excited by a self-inducing arrangement. This enables the downgoing belt to charge to the polarity opposite to that of the terminal, and thus the rate of charging is doubled. The self-inducing arrangement requires insulating the upper pulley and maintaining its it at potential higher than that of the HT terminal. Okay, as the pulley is at higher potential positive, the negative charges due to corona discharge at upper spray points are collected by the belt. This neutralizes the any remaining positive charges on the belt and leaves an excess of negative charges. Okay, this is about the circuit operation of Van de Graaff generator. Then advantages of Van de Graaff generator is called first one ripple free output, and second flexibility and precision, and limitations low current output. First one low current output, and next one vibration in belt at high speeds. Okay, so this is a summary. So very high DC voltages can be obtained by using electrostatic induction by Van de Graaff generator. Okay, the charges are accumulated at high tension electrode to produce high potential. The output is ripple free, but with low current delivery. So this is about total explanation of Van de Graaff generator.